going to be talking about energy, both potential and kinetic energy. Please make sure that you are doing visual notes as you watch the video, and that you then go to Edmodo and watch the Edmodo quiz. Energy is defined as the ability to do something or work. So the definition of work is to apply a force over a distance. So the formula for work is work equals force times distance. There are two main types of energy that we're going to be talking about today. The first one is potential energy, and that's the energy that is stored within an object which has the potential to do work. It's the energy of non-moving objects. So with potential energy, work is not currently being done, but it has the potential to be done. There's a possibility of work being done. The second type is kinetic energy, and that's the energy that an object has as a result of being in motion. It's moving energy. So the difference between potential and kinetic energy is that with kinetic energy, work is being done. So when there is potential energy, when potential energy is at 100%, there is no work being done because there's no distance being in the formula or in the object. The object is not moving, it's not going a distance. In kinetic energy, it's moving energy, so there is distance. The object is covering a distance, so work is being done. So if we look at the ball in this example, the ball at the top of the hill, it's not currently moving, but it has the potential to move. It has the potential to apply a force over a distance. So it has the possibility of moving and the possibility of doing work. In this example, the ball is rolling down the hill. It is moving, so work is being done. Work is not being done over here. Work is being done over here. The formula for potential energy, and we're specifically looking at gravitational potential energy, and all energy is measured in joules. That is the units of energy for energy, and we abbreviate that as a capital J, is mass in kilograms times gravitational acceleration, which is meters per second squared, which on Earth it's a constant, and it's always going to be 9.8 meters per second squared, as long as you're on Earth, times the height in meters. And so if we're abbreviating it, we write PE, capital P, capital E, for potential energy, equals M times G times H. Potential energy is affected by height. So if we change the height of an object, we change the amount of potential energy it has. So if we have the same soccer ball and we hold it at 4 different heights, here the soccer ball has the least amount of potential energy, and over here it has the greatest amount of potential energy. So the higher the height, the greater the potential energy. Like I said, over here we have the least potential energy, here we have the most potential energy. So where did that energy come from? The energy came from whomever picked up the ball. Potential energy is also affected by mass. So if we have 4 objects, they're all being held at the same height. We have a 10 kilogram object, a 20 kilogram object, a 30 kilogram object, and a 40 kilogram object. The more mass the object has, the more potential energy the object has. So our 10 kilogram object has the least amount of potential energy because it has less mass. And our 40 kilogram object has the most potential energy because it has the most mass. So where does the energy come from in this case? The more mass the object has, the more gravity is pulling on the object. So it is possible for 2 different objects to have the same amount of potential energy. For example, if you have a bowling ball and it has 20 times more mass than a golf ball, then the golf ball would have to be lifted 20 times higher than the bowling ball to have the same potential energy. So we have 20 times more mass and 20 times less height, 20 times less mass, 20 times more height. Their potential energy is equal. Calculating kinetic energy. So the formula for kinetic energy, which is also the units is joules, is 1/2 or 0.5 times the mass of the object, so in kilograms, times velocity squared. And remember, velocity squared is meters per second. So whatever your velocity is, you'd have to square it. So in shorthand, if we're abbreviating it, you would say KE equals 1/2 mv squared. You want to make sure that you remember to square that velocity. So kinetic energy is affected by speed. So if we have two cars with identical masses, we have the same car, one is traveling at 90 miles per hour, the other is traveling at 60 miles per hour. The car on top has more kinetic energy because it's traveling faster. So the greater the speed, the greater the potential energy. So up here we have most kinetic energy, this one has least kinetic energy. Kinetic energy is also affected by mass. So we have our dump truck and we have our smart car. They're each traveling 60 miles per hour. Which one do you think has the most kinetic energy? The dump truck has more kinetic energy because it has more mass than the car. Right, and we know that if a smart car, if you think about it this way, if a smart car and a dump truck were both traveling 60 miles per hour and crashing into a brick wall, the dump truck is going to hit the wall with more force because it has more energy. It's going to do more damage to the wall. So again, our dump truck has most kinetic energy, our smart car has the least amount of kinetic energy. Again, it is possible for two objects of different masses to have the same kinetic energy. How do you think that is? Right, you change the speed. So we have our dump truck and our smart car. If our dump truck is has 10 times greater mass than our smart car, if our smart car is moving 10 times as fast as our dump truck, the kinetic energy for each of them should be the same. Again, this is assuming this is in a perfect world. This isn't looking at friction. It's just, theoretically what would happen. But obviously there are other variables like friction and things that are going to make a little bit of difference. So here's a summary of how different variables affect an object's energy. So let's look at potential energy. So for potential energy, as height increases, potential energy decreases. And the same thing could be said. As height decreases, potential energy increases. For kinetic energy, as speed increases, kinetic energy increases. And as speed decreases, kinetic energy decreases. And then for both potential and kinetic energy, as the mass increases, the potential energy and the kinetic energy both increase. And as mass decreases, the potential energy and the kinetic energy decrease. So now you need to go to Edmodo to take the Edmodo quiz.